In today's notes, we're going to talk about density. Before we can talk about density, we have to go back and review what we've learned about mass and volume. A few days ago, we asked ourselves the question, what is mass? And our answer was that mass is the amount of matter in an object or person. What that means is that mass is how heavy something is. Mass and weight are not the same thing, and we learned that weight is the pull of gravity on an object, but on Earth, mass and weight are equal. So another way to describe mass is to say that mass is how much something weighs. We also asked ourselves the question, what is volume? And we learned that volume is the amount of space an object takes up. What that means is that volume is the size of something, how big or how small it is. So mass is how heavy or how light something is, what it weighs on Earth, and volume is how big or how small something is. Now, if you think about it, mass and volume have nothing to do with each other. Something can be big and can be light, like feathers, or something can be small and be heavy, like a marble. But what density does, density comes along and density establishes a relationship between mass and volume. They have nothing to do with each other, but density makes them have something to do with each other. It relates mass to volume. So what is the scientific definition of density? Density is an object's mass per unit volume. Do you see two words in the definition that we've just talked about? Yeah, you see mass and you see volume. And remember we just said that density relates mass to volume. Now you might look at that definition and you might say, well, I don't really understand what that means. And that makes sense because this is actually a very difficult definition to understand. But we're going to do several real-world, hands-on explorations that will make it a little clearer to understand what density is. And hopefully, after we do those explanations, we'll have a better idea of what density is, and this definition will start to make a lot more sense. But right now, we're going to write down the definition of density on our thinking map. I want you to turn to page 69 in your notebook. And in the center of your thinking map, you see the word density. We're going to write the definition of density. Density is an object's mass per unit volume. I want you to take your answer boards and I want you to answer this question. What is density? Show me your boards. Very good. Density is an object's mass per unit volume. As we said before, volume and mass have nothing to do with each other, but density relates the two. It relates volume to mass. It relates how heavy or light something is to how big or small it is. Let's do an exploration to get a better understanding of what density is. I want you to turn your notebook to page 72, and we're going to do the first exploration that says consider this, number 1, mass and volume of pebbles and bark. In your tray, you have a bag of pebbles and a bag of bark. I want you to take both of those out, and I want you to examine them. Do the pebbles and the bark have the same volume? Do the pebbles and the bark take up the same amount of space in the bag? Look at them carefully, and we're going to vote. Raise your hand if you think that the pebbles and bark do have the same volume, that they do take up the same amount of space in the bag. Raise your hand. Raise your hand if you do not think they have the same volume. If you don't think they take up the same amount of space in the bag. Very good. Most people think they do, but some of us think they don't, and that's understandable. I'm going to give you the evidence that they do have the same volume. And the only reason I know that is because I measured out 100 milliliters of pebbles and 100 milliliters of bark, and I put them in the bags. So you wouldn't be able just to tell that by looking at them exactly, but I'm giving you the evidence that they do have the same volume. On page 72, where it asks, do the bark and the pebbles have the same volume? I want you to write yes, because I've given you the evidence that they do have the same volume. So we've taken care of one part of what we said in density is, volume. What's the other part of density? Very good, it's mass. So our next thing to establish is whether or not we think one of these has a greater mass than the other, or do they have the same mass? I want you to take both bags, and I want you to decide which one feels heavier. We're going to vote now. How many people say that the bark feels heavier? Okay. How many people say that the pebbles feel heavier? Very good. Most people believe that the pebbles feel heavier. But can we just trust our senses? What do we need to do to provide evidence that this really is true, that the pebbles have a greater mass than the bark? Very good. We need to measure their mass. What apparatus could we use to measure the mass of the pebbles and the bark? Very good. We can use a triple beam balance, which is sitting on your table. I want you to take your pebbles, I want you to put them on the triple beam balance, and you're going to measure the mass. We're going to record our mass on page 72 where it says mass of pebbles. I want the data recorders at every table to write this on your whiteboard, pebbles and bark. And you're going to record the mass of the pebbles and then the mass of the bark for the whole team so that we can compare the data from every team. Okay, very good. Everyone is finished recording their mass of the pebbles. Let's take a look at what we have. First of all, do we expect that all of the teams will have the same mass for the pebbles? How many people say yes? Raise your hand. And how many people say no? Very good. Most of us say no. Who can tell me why the pebbles would not have the same mass for every team? Very good. The pebbles are different sizes, so we don't expect that they're going to have the exact same mass for every team. Should they be similar? How many people say yes, they should be similar? Raise your hand. How many people say no? Very good. Most people believe that they should be similar. Why should they be similar? Who can explain? Very good. They should be similar because we've already said in the very beginning that we have the same volume of pebbles. So even though they're not going to be exactly the same, they should be similar. We should have the same range of mass of the pebbles and bark. Okay, how many people found that the pebbles were between 150 grams and 200 grams? Very good. And in fact, if we look at all of the data, we see that most people recorded their mass of pebbles as around 190 grams. So they are similar. Okay, let's take a look now at the mass of the bark. Measure your bark and record the mass of the bark on page 72 of your notebook. Data recorders, you're going to record the mass of the bark underneath the mass of the pebbles on your whiteboard so that we can compare the data. Very good. When I count to 5, I want every team to show me your data. 1, 2, 3, 4, 5. Very good. How many people found that the pebbles were much, much heavier, had a much greater mass than the bark? Very good. And from looking at the data, all of us found that the bark has a much smaller mass, the pebbles have a much greater mass. So our prediction was correct. Okay. On your papers, I want you to answer this question. Do the bark and the pebbles have the same mass? And the answer is no. The pebbles are much, much heavier. They have a much greater mass than the bark. Alright, so we know that the volumes were the same, but the masses were very different. What does this tell us about density? What can we learn from this about density? If we look at our pebbles and bark, we can learn that two substances can have the exact same volume. They're both 100 milliliters, but they can have very different masses. One can have a much greater mass than the other. So what does this have to do with density? The density of the pebbles is greater because the pebbles have a lot greater mass for their size. On the other hand, the density of the bark is lower because the bark has a much lower mass for its size. The pebbles are very heavy for their size, have a greater mass for their size. The bark is lighter for its size, has a much lower mass for its size. Pebbles have a greater density, bark has a lower density. We can use another example. Let's think about a marshmallow. Marshmallows, are they heavy or are they light? Yeah, marshmallows are very light. But sometimes marshmallows are also very big. So a marshmallow can have a very small mass for its size. They can be big and they can be light. Do marshmallows have a greater density or a lower density? They have a lower density. On the other hand, let's look at a raisin. Are raisins small or are they large? Yeah, raisins are very small. But do raisins have a greater mass than marshmallows? Yes, they do. So raisins are small, but they're very heavy. Raisins have a greater density than marshmallows. So this is just like the pebbles and the bark. Something can be big and light, like the bark, and like the marshmallow, or they can be smaller and heavy, like the raisin and like the pebbles. On your papers, I want you to write greater density, and I want you to draw an arrow pointing to the pebbles. The pebbles have a greater density because they have a greater mass for their size. So density is an object's mass per unit volume, and this helps us to get a little better understanding of what that means. Let's take a look at another real-life example. We're on the second box on page 72 where it says, consider this number 2, mass and volume of steel spheres. I want you to take the steel spheres out of the bag, and I want you to hold both of them in your hand. I want you to decide which one feels heavier, the small sphere or the large sphere. And we're going to vote. How many people feel that the large sphere feels heavier? And how many people think that the smaller sphere feels heavier? Most people believe that the smaller sphere feels heavier. But how can we know for sure if it actually is heavier, if it actually does have a greater mass? Yeah, we're going to have to do a measurement of mass using the triple beam balance. Okay, let's go to page 72 and let's record our impressions. Which sphere feels heavier, the small or large? Write down what you think. Now we want to measure the actual mass of the small sphere. But what will happen if we put the sphere on the balance? Yeah, it's going to roll off. So what do we need to use? We need to use something to hold the sphere, and we're going to use a 2-ounce plastic cup. Now, are we going to have to worry about the mass of the cup? Does the cup have a mass? How many people say yes, the cup has a mass? Yeah, it certainly does.